Hi guys, today we're going to learn how to calculate the speed of a wave with electromagnetic waves. So go ahead and open up 418 electromagnetic waves on Schoology. We're going to go through it real quick guys, but I really encourage you to pause, go back, rewind if you have to, in order to make sure you understand how to do this well. So guys, first off in those notes, light travels in waves known as electromagnetic waves. These waves carry electromagnetic energy over a long distance. Remember, whenever we use the word electromagnetic, it's basically the same thing as light. So they travel in light waves. They carry light energy. Parts of a wave, guys. This is stuff you should have learned in middle school. Most of you probably did. So I'm going to go through it real quick. The top part of a wave right there where the arrow is called the crest. So go ahead and label that in your notes. The crest is the top of the wave. The bottom of the wave is the trough. It's just like a trough is what an animal eats out of. You can kind of see here. It looks like a trough, what the animals might eat out of. The distance between the trough and the middle line here, or the crest in the middle line, is known as the amplitude. So you're probably familiar with this when it comes to sound, right? If something has more amps, it's going to be a louder sound. And lastly, this one up here, we talked about it already, but it's a wavelength. Just the distance from one part of the wave to another. It could be there. It could be down here. It doesn't matter. Just distance of one part of the wave to another is the wavelength or length of one wave. So make sure you have all those four things labeled on that diagram. A really important note, guys, is the frequency of waves. So frequency is really similar to wavelength, right? So frequency is, just make sure to write this definition down, is the number of waves that pass a point in a certain amount of time. So up here at the top wave, you can see there are a lot of waves passing this point. So we have 1, 2, 3, 4, 5, 6, 7, 8. Down here, you just have 1, 2, 3. So which one has a greater frequency? Which one has waves passing more frequently, right? Frequently. This one does up top, right? This has a higher frequency. Make sure to label the top wave on this diagram as being high frequency. As we go down, the frequency just gets lower till this bottom one is the lowest frequency. Just a real quick practice, which wave below has a smaller frequency? Choose an answer. It's the red one. Smaller frequency, the waves are less frequent, right? So it's the red one has a smaller frequency. Next one, which wave below has a smaller wavelength? This one's the distance, right? So is this distance smaller or is this distance smaller? Definitely the blue one has a smaller wavelength. Which wave below has the highest frequency? So where the waves are most frequent? Definitely the blue one. Which wave below has the largest wavelength? Wavelength is the distance from crest to crest. Which one has a bigger distance? Definitely the red one, right? Distance from here to here is greater than the distance from here to here. Which wave below has the lowest frequency? So which one has the least frequent waves? That'd be C, right? You're only seeing part of a wave because they're super not frequent. D has the highest frequency. Which wave below has the shortest wavelength? Well, definitely we're looking at the distance between here to here. D has the smallest waves, the shortest wavelength. Those are some practice to help you understand the difference between frequency and wavelength. At the bottom of your notes, I need you to write this. Waves with a higher frequency have a shorter wavelength, right? Which makes sense. If waves are more frequently coming by, the distance between each wave or the wavelength is going to be smaller. Write that in your notes. Okay, so next thing we're going to do is it's the first time we're really using a formula in this class. We're going to start looking at wave calculations. So when we're going to learn how to calculate the wavelength, the frequency, or the speed of a wave. Remember, the wavelength of a wave, guys, is going to be measured in meters. We can abbreviate that as M. Be sure to write that in your notes. Frequency is measured in hertz, which we can abbreviate as Hz. And the speed of the wave is going to be measured in meters per second, or M/s. So whenever we're using those terms, guys, those are always the units we're going to use. I highly suggest you write that down in your notes so you can go back and refer to it as we do these calculations. The formula we're using, guys, is a little bit confusing. So the formula is V equals F times, what the heck is this? This, guys, it looks like an upside down Y. It's actually a Greek letter, and how you say it is lambda. So V equals F times lambda, kind of like lambda. The V, guys, just represents the speed of the wave or the velocity of the wave. The F is the frequency, and the lambda represents the wavelength. I actually have no idea why scientists use lambda to represent wavelength. Why don't they just use W? But that's what they use for some reason. If you have trouble writing a lambda, guys, I suggest literally turn your iPad upside down and draw a Y. It's basically just an upside down Y. So in a problem like this, here's what the problem's going to look like. It's going to say, what is the speed of a wave that has a frequency of 12 hertz and a wavelength of 2 meters. So as for these problems, I'm always going to give you a graphic organizer here where you can write your work. It's separated into formula, givens, and work. For the formula, you're just going to write your formula. Big hint, guys, all day today, you're going to write the same thing in this box. This formula, V equals F times lambda. It's the formula you're going to use to solve this problem. Givens, guys, are just what numbers are given to you in the problem. So what numbers are given to you? It says 12 hertz, right? 12 hertz is the frequency. So frequency is given to me. So I'm going to write F equals 12. So I know what goes in for F right here. And it says a wavelength of 2 meters. Wavelength is 2. Wavelength is represented by lambda. So my lambda is 2. Once I get my givens, do I know my speed? No. It's asking me for my speed, right? So I don't know V. That's what I'm trying to find out. I'm just going to plug the 12 in for F, and I'm going to plug the 2 in for lambda. So if I do that, I now get V equals F, or 12, times lambda. Lambda is 2, so 2. So V equals 12 times 2. To solve for V, I just multiply 12 times 2, which equals V equals 24. Pause. You're almost done. The speed of the wave is 24, but what's our unit, right? We need our unit. Remember, go back to that other slide. Unit for speed is always the same. It's meters per second. So if I put my final answer, I'm going to put 24 meters per second is my speed. Okay, let's try another one. Feel free to rewind at any point, right, if you didn't catch what I said. What's the speed of a wave that has a frequency of 24.5 hertz and a wavelength of 0.21 meters? Once again, guys, definitely using the same formula. V equals F times lambda. What numbers am I given? Right here, I'm given 24.5 hertz, which is my frequency, right? So F is 24.5, and a wavelength of 0.21 meters. So my lambda is 0.21. Those are given to me in the question. That's why they're my givens. All I got to do, guys, is take those numbers and plug them in. 24.5 goes in for my F right here. 0.21 goes in for my lambda, which is going to look like this. V equals 24.5 times 0.21. Go ahead, put that in your calculator right now, guys, and see what answer you get. If you did it, you should have gotten 5.415. However, our unit, right, is meters per second, so my final answer is 5.415 meters per second. Whenever you do these, guys, in general, I don't really care how you round it. Just if you want to round it, if you wanted to do 5.42, that's totally fine too. Either way, it's correct. Two more problems. The next two are a little bit trickier, okay? This one says, what is the frequency of a wave that has a speed of 14 meters per second and a wavelength of 2 meters? Okay, so what's different about this question than the previous question? It's different about this one and this one. This one, the previous two questions, were looking for speed, right? This one's looking for frequency, so keep that in mind. It's going to be a little bit different. The formula is the same, though. The formula is still V equals F times lambda. What's given me, though? So I'm given the number 14. 14 is my speed. Is speed my V, my F, or my lambda? Speed is my V, right? So V equals 14. That's one of my given numbers. My wavelength, lambda, is 2 meters. So I'm going to put lambda equals 2. Now, if you did V equals 14 times 2, that is wrong for this one, right? Because V is 14, right? So 14 is going to go in for V, 2 is going to go in for lambda, and my F is going to be just left as F. So it should look like this. 14, my V, equals F times 2, my lambda. How do you solve for F here? Hopefully you know this from math class, guys, right? But when you're set up like this, you just need to do the opposite of what's present. So you need to divide by 2. If you divide both sides by 2 to find F, you get 7 equals F. Go back to that first page, guys. What's my unit for frequency all the time? Hertz. So 7 hertz. The frequency of this wave is 7 hertz. Okay. And our last one, guys, is what is the wavelength of a wave that has a frequency of 200 hertz and a speed of 2.3 meters per second? Once again, always the same formula. This one, though, is asking for the wavelength. So my givens, it's given 200 hertz, which is my frequency. So I'm write F equals 200. And it's giving my speed, which is my V, is 2.3 meters per second, right? Once again, guys, if you didn't catch something, please pause and go back so you can get it. That's the whole purpose of this video. So I'm going to take 200 and I'm going to stick it in for F. I'm going to take 2.3 and I'm going to stick it in for V. I'm going to leave lambda just like it is because that's what I'm trying to solve for. If I do that, it looks like this. 2.3 equals 200 times lambda. To solve for this, guys, remember you always divide. So I'm going to divide. The way I remember, guys, divide by the number that's next to the unknown, right? So I'm not going to divide by 2.3.